at 3:15 a.m., August 14, 2025. Russia's logistics vessel Port Olya 4, with a displacement of over 13,200 tons, had just docked at Olya Port in the Astrakhan region, located more than 500 miles deep inside Russian territory. It was preparing to unload a military cargo valued at approximately $22 million, including hundreds of Shahed suicide drones, large-caliber artillery shells, and electronic components shipped from Iran. Everything seemed to be within a safe zone. Olya Port, where the vessel had docked, was protected by medium-range Buk M3, surface-to-air missile systems, long-range 96L6 surveillance radar, and coastal reconnaissance forces. But what the Russians did not know, the entire voyage, from the moment the ship departed Bandar Abbas in Iran, crossed the Caspian Sea, and docked at Olya, had been under continuous surveillance by a covert Ukrainian strategic reconnaissance unit operating on the opposite Caspian shore. And at the very moment Russia's logistics network appeared most secure, when containers were being opened and cranes prepared to move, the Ukrainian An-196, a long-range attack UAV carrying a 165-pound shaped charge warhead, had already locked onto its target. It did not appear by chance, nor did it come alone. Flying 650 feet ahead were two Ukrainian-made UJ-22 airborne decoy drones at an altitude of 1,000 feet, acting as bait to divert the attention of the Buk M3 and Panzer S-1 batteries guarding the port. All three aircraft advanced in an offset triangle formation toward the pier. This was the decoy lead strike tactic, a three-layer structure widely used in modern UAV operations, where the first sacrifice becomes the foundation for the final blow. Throughout the flight, Lyuty was guided by the two decoys. Each time they emitted strong signals, Russian radars immediately redirected their scans skyward, allowing Lyuty to dive 2 to 2.5 miles deeper, slipping through temporary blind corridors toward Olya Port. Thus, each cycle of deception and penetration unfolded exactly as rehearsed from hundreds of prior reconnaissance drone flight hours. All three UAVs coordinated seamlessly, covering nearly 500 miles of airspace deep inside Russia. At 3:40 a.m., when the decoys were less than 18.6 miles from the target, sudden jamming interference at the 2.4 GHz band disrupted signals from the second decoy. The onboard processing system confirmed the source, a Lear-3 electronic warfare complex mounted on a Kamaz chassis, positioned in the container yard east of the port. Almost simultaneously, Russia's long-range Nebo-M radar detected two suspicious tracks at altitudes of 900 to 1,000 feet. In under 10 seconds, the radar station triggered Level 2 alert, red warning icons flashing across the air defense command screens. The duty commander immediately ordered, "Activate Panzer S-1, defend Olya Port." From the northern fuel depot of the port, the Panzer S-1 battery surged to maximum output. Its fire control radar spun rapidly, locking onto both targets. 57 East 6 missile tubes elevated vertically as warning sirens pierced the night over Astrakhan. Just 14 seconds later, two 57E6 missiles roared off the launchers, leaving white streaks across the sky. In less than 20 seconds, both decoy UAVs exploded, two blazing fireballs scattering burning debris into the Volga River. Inside the combat cabin, a sigh of relief was heard. "Clear! The targets are down!" But they had no idea. This was precisely the trap Ukraine had set. The real game was only beginning. Less than 1,500 feet to the south, Lyuty An-196 was closing in. As Russian radars locked onto the decoys, Lyuty abruptly banked 17 degrees, breaking from its initial axis, a maneuver pre-calculated to slip through the seam where overlapping radar beams fragmented, creating a narrow blind corridor just wide enough to pass undetected, escaping a second radar lock. This was the art of radar evasion, the same technique that had allowed Ukraine to send UAVs to Moscow, Kazan, and now Astrakhan on the Caspian shore. While Pantsir crews were still recalibrating after their salvo, the deadly dagger had breached the outer defenses and was now less than 9.5 miles from Port Olya 4. At its current speed, it needed barely over 4 minutes to reach the pier. At 3:46 a.m., inside an underground Ukrainian control cabin, a sharp beep echoed. The UAV crew confirmed. "Lyut has entered the attack corridor. Lock direction, Port Olya 4, Olya Pier." This was the beginning of the final phase, where even an error of less than a second could see the drone disintegrated in the dense air defense net before it could deliver a historic strike. On the control screen, the final target was now fully visible. A large cargo vessel, nearly 600 feet long, 90 feet wide, with a displacement exceeding 27,560 tons, its hull built of multi-layer reinforced steel plating. This was Port Olya 4, in the midst of unloading special containers carrying Shahed UAV components from Iran. A lucrative prey, but not an easy kill. The operators understood this perfectly and knew they needed maximum focus. A precise strike would be the worthy reward for countless sleepless nights. The ship was guarded by 2 infamous layers of air defense. The Buk M3 system, with the 9 S-36 radar and 9 R-31M missiles capable of ranges up to 43 miles, known as the Heavy UAV Hunter. The Pantsir S-1 system, each unit worth $15 million, designed to intercept supersonic targets within a 12.5-mile radius, with reaction times as fast as 4 seconds after detection. According to intelligence, inside its cargo holds was a new batch of Shahed 136 drones recently delivered from Iran. It was estimated that on Port Olya 4's deck were over 50 containers of Shahed 136 over 131s, equivalent to at least 350 to 400 suicide UAVs. That alone was enough for Russia to sustain 2 weeks of continuous long-range strikes on substations, thermal power plants, and fuel depots across central and western Ukraine. In addition, the vessel carried 6 containers of electronic components and Shahed engines, Mado 550 over 650 types imported directly from Iran. 4 reserve fuel tanks, each holding nearly 5,280 gallons of aviation gasoline, enough to assemble and operate hundreds of UAVs. 2 ground communication antenna systems, Lear 3, used to synchronize UAVs after unloading. And most importantly, nearly 17,650 pounds of shaped explosives divided into containers labeled as civilian industrial cargo. Once the target was confirmed in range, the control officer ordered, "Offset 4 degrees starboard, drop altitude, activate passive-only guidance." Immediately, Lyut banked slightly, descending another 49 feet, skimming above the sea surface, riding the radar reflection waves from the pier walls. Lyut was a long-range suicide drone developed by Ukraine in 2024, designed specifically for deep penetration sabotage missions. With a fuselage length of about 5 feet and wingspan of 7 feet, it used a carbon composite frame to reduce weight, enabling a cruising speed of 110 miles per hour and a terminal attack velocity of 145 to 155 miles per hour in the final dive. This UAV had become the ideal weapon for surprise strikes, where a single hit could trigger a devastating chain reaction. In the control center, Ukrainian engineers initiated the final dive mode, autonomously locking onto the vessel's midsection, where the fuel compartments and UAV storage were located. At 3:49 a.m., with only 1.3 miles remaining, the final attack was executed. The Lyut, a long-range strike UAV adapted from the small L-39 Albatross trainer platform, accelerated to nearly 130 miles per hour, plunging into the port side of Port Olya 4. The moment of impact, a white flash erupted from the vessel's port side, instantly expanding into a massive fireball over 300 130 feet high, illuminating the entire Olya port complex. The shockwave ignited all fuel tanks below deck, generating instantaneous pressure exceeding 40 pounds per square inch, enough to tear apart steel plating thicker than 0.8 inches on the cargo ship. The 165-pound shaped warhead punched through 3 compartments, detonating in the engineering bay, where control circuits and fueling systems were concentrated. Multiple Shahed UAV containers detonated in sequence, scattering fiery fragments into a steel storm that rained across Pier 3. The blast toppled cranes, ignited warehouse roofs, and hurled cargo trucks aside. The deafening roar echoed across a radius of over 12.5 miles. Residents in Astrakhan later recalled they thought an earthquake had struck. Flames engulfed the deck, Port Olya 4's hull listing portside, water rushing into the holds, turning the vessel into a blazing torch on the Caspian shore. At 3:50 a.m., just 48 seconds after impact, the pier's fire suppression system activated. But it was useless. The main blast had already consumed the entire deck, where dozens of Shahed containers were stacked. Each Shahed 136 weighed 440 pounds and carried an 88 pounds warhead. When ignited, they detonated like a battery of rocket artillery. In under 3 minutes, at least 15 secondary explosions shook the port complex. Footage posted on Telegram by Astrakhan residents showed a column of flames hundreds of meters high, lighting up the night sky. Container fragments and burning UAV wings raining onto warehouse roofs nearly 2,300 feet away. Explosions pounding for nearly 20 minutes, forcing urgent evacuation of residential areas. By 4:15 a.m., Port Olya 4 was half submerged, only its bow faintly visible amid the inferno. For the first 3 hours after the blast, Russia's Ministry of Defense remained silent. Pro-Kremlin Telegram channels issued only vague reports. A fire has occurred at Olya Port's warehouse, cause under investigation. It wasn't until midday, August 14th, that Russia officially acknowledged material damage at a civilian port on the Volga, with no impact on military operations. Yet commercial satellite images released immediately afterward exposed everything. A large cargo vessel almost completely destroyed. Pier 3 blackened, steel structures deformed. This was not just a single strike, because Port Olya 4 was not an ordinary civilian cargo ship. It was a key link in transporting Shahed UAVs from Iran across the Caspian into Russian territory. With the vessel and its cargo destroyed, Russia lost at least 300 Shahed drones in a single night, equivalent to 2 to 3 weeks of sustained aerial strike capacity against Ukraine. The strike demonstrated that Pantsir S-1 and Nabo-M, despite their sophistication, could be easily deceived by decoy drones. That Lyuty AN-196, flying low at medium speed, was nearly invisible to radar. That the Caspian defense system, once deemed impenetrable, contained fatal flaws. Immediately after the strike, Russia was forced to lock down Olya port, banning civilian and military docking for at least 72 hours. Deploy additional Panzer S-1 units and Podlet K-1 radars around Astrakhan to patch the air defense gap. Suspend the transport of Shahed UAVs via the Caspian corridor, a direct blow to Russia's logistics chain. For Ukraine, this was a rare strategic strike. With a single Lyuty drone costing less than a Tesla Model 3, they destroyed a Shahed shipment worth tens of millions of dollars, while shaking Russia's southern defense network to its core. On the night of August 14, 2025 in Astrakhan, Ukraine wrote another chapter in modern warfare. A lone drone, flying low in the darkness, could shift the entire strategic balance and turn Russia's belief in a safe rear area into a fragile illusion. At 4:40 a.m., August 3, 2025, when the last TM-62M anti-tank mine, out of a total of 25, was installed beneath the Tsata Bridge, The 550 pounds of explosives lay snugly under the main pillars, metal joints, and horizontal load-bearing beams, turning the entire bridge into a death trap. With just a single detonation signal, this entire mass of steel and concrete would collapse in an instant. The Tsata Bridge is not an ordinary bridge. It lies near the village of Rudnya Tsata, a lifeline of Russian logistics, connecting directly from Klimovo, Zlinka, and Starodub to the fronts at Sudzha and Kursk, sustaining Russian border garrisons in Klimovo and the northern Sumy front. Intelligence also revealed, in less than 60 minutes, a large Russian supply convoy, which appears only once a week, would cross the bridge. That meant if the strike succeeded, Ukraine would not only destroy strategic infrastructure, but also wipe out a major logistics column, a double blow that could shift the battle and open an opportunity for Ukrainian infantry to advance. At 5:20 a.m., from a camouflaged field command post on the forest edge of the marshlands, northeast of Semenivka, Chernihiv Oblast, Ukraine, about 17 miles from the bridge, a detachment of the 58th Separate Mechanized Infantry Brigade fixed their eyes on the electronic screen, monitoring every movement through the eyes of an Odin 10 FPV reconnaissance drone hovering at 660 feet, flying surveillance around the area. Thermal signatures returned by the drone's FLIR Boson 640 infrared camera show. About 3.5 miles from the bridge, a convoy emerges through its hot spots. Exhaust pipes glowing at 575 degrees Fahrenheit, engine bays peaking near 215 degrees Fahrenheit, brake systems flashing bright every time they slow down for a curve. Thermal signatures don't lie. This was the target they had stayed awake all night for. A total of 14 supply vehicles, 2 BTR-82A armored personnel carriers, 1 leading and 1 tailing, escorting the convoy. Each weighs up to 33,100 pounds, clad in thick steel armor and equipped with 30mm autocannons capable of crushing any ambush, with Russian soldiers perched on top clutching their AK-47 rifles. The APCs are the steel shields of the convoy, symbols of Russia's mechanized might. Between the two giants are Kamaz trucks, 5 with tanks full of fuel, their heat signatures blazing from engines and tank bodies, rolling fire barrels holding tens of thousands of liters of diesel. They shine like glowing arteries, the lifeblood of Russia's war machine. 5 more carry an entire mobile arsenal, hundreds of 122mm and 152mm artillery shells stacked layer upon layer, crates of machine gun ammo, RPG anti-tank rounds, even Igla manpads. Each truck carries enough ammunition to sustain a brigade's firepower for days. On infrared, the steel crates absorb heat, forming glowing patches, showing that inside are not ordinary goods, but an arsenal capable of flattening trenches. Those 5 Kamaz are 5 mobile powder magazines. Mixed in the convoy is a military ambulance, a camouflage shield attempting to hide the lethal nature of the column. But the most surprising piece of equipment sits among the Kamaz fuel and ammo trucks, an RB-341V Lear-3 electronic warfare system mounted on a Kamaz chassis. Its antennas rise high above the truck, running at full capacity, constantly emitting jamming signals to neutralize UAVs and radio communications. With Lear-3's presence, the Russians believed this convoy was nearly invulnerable to Ukraine's electronic eyes. In total, 14 vehicles, hauling cargo powerful enough to capture several villages deep in Ukrainian territory, far larger than what intelligence had initially reported. At 5:45 a.m., the convoy advances onto the Tsata Bridge. In the early morning, dozens of diesel engines roar, shattering the silence, rolling across a structure Russia considered untouchable. The giant bridge piers, buried tens of meters into the riverbed, stood tall, its steel beams unyielding, the strongest proof that it could never be destroyed. But today, Ukraine would accomplish the impossible. Everything now hung on 25 mines. Suddenly, a wave of high-powered electronic attack bursts across 2.4 GHz and 5.8 GHz bands from the multiband jammer aboard the Lear-3. suppressing signals across the entire area. The relay drone shudders. Its Odin 10 camera feed cuts out for several seconds. But inside the command post, the commander remains calm. The Odin 10 FPV drone had been modified by Ukrainian engineers to carry a fiber optic cable system on a steel frame. The fiber's core is only 9 microns thick, thinner than a human hair, yet still transmits at 1.5 gigabits per second, enough for uncompressed 1080p video, as well as control signals, telemetry, and GPS corrections. The commander knows the drone is safe, directly wired through fiber, beyond interference. Lear-3, once a pride of Russia's electronic warfare, has been reduced to useless scrap. This was not an easy mission. The operation had been calculated for days. Once Ukrainian military intelligence received classified reports on the Russian supply convoy. Everything had been prepared from the night before. This was not another kamikaze UAV attack, so often defeated by Russia's electronic shields. The bitter lessons of failed raids had taught Ukraine they must change tactics, find a way past the jamming. And this time, instead of flying drones into the convoy, they chose another approach, deceptively simple yet unavoidable, laying the trap beneath the bridge where every convoy, no matter how strong, had to pass. Minutes later, when the convoy reached the bridge's center, its weakest point, the commander of the 58th Brigade gave the cold order, "Destroy it." The soldier in charge of detonation immediately flipped the switch, but instead of a massive explosion, only a weak light flickered, then went out. The minefield stayed silent. For a moment, the entire team froze. The operator frantically toggled the switch, checked the detonator wires. Nothing. The enemy had anticipated this. Russian electronic warfare had jammed the detonation signals. The 550 pounds of mines still sat under the bridge, but they were silent. A night's work now teetered on failure. At 5:50 a.m., the lead BTR was almost off the bridge. The crew was in panic. On the comms, Kyiv remained silent. They too realized everything was collapsing. The commander clenched his binoculars, then lowered them. The decision came in an instant. Use the UAV trigger manually. The unexpected order broke from the plan. The bunker fell silent. Every eye fixed on the screen, watching the drone accelerate. On the bridge, the mines waited beneath the structure. The convoy was less than 30 seconds from crossing. One missed beat, and all effort would be wasted. Immediately, the fiber-linked UAV surged forward, bulky, but untouched by jamming. It skimmed the river, then suddenly pulled up, diving into the dark void beneath the bridge. The camera shook violently, images blurring with each rotor beat, but still captured the chilling sight. Massive TM-62Ms strapped to the bridge's steel skeleton, glinting faintly like lurking traps waiting to ignite. The TM-62M is a standard Soviet anti-tank mine, still trusted by Ukraine. Its design is simple, a round steel casing, painted green, weighing about 22 pounds. Inside, up to 18 pounds of TNT, enough to blast a tank tread or break an armored hull weighing tens of tons. One mine alone creates a blast radius of 7 feet, with shrapnel flying as far as 100 feet. 25 mines chained together unleash unimaginable destruction, erasing everything in reach. The most terrifying truth, these hellish weapons lay hidden beneath the bridge, locked onto the steel beams, while the Russians above had no idea. At 5:51 minutes and 30 seconds a.m., the UAV slammed into the mine cluster at the central pillar. A blinding flash, followed by a deafening explosion shaking the valley. All 25 mines detonated at once, releasing the fury of hundreds of kilograms of TNT. The shockwave ripped across the bridge. Fuel-laden Kamaz trucks turned into fireballs. At ground zero, temperatures spiked to 5,400 degrees Fahrenheit, melting steel into glowing liquid, creating a sea of fire hotter than 2,000 degrees Fahrenheit. Concrete split and burst apart. Ammo trucks went up in chain reactions, artillery shells shooting in all directions, raining death. The lead BTR was hurled off the bridge, the rear guard shattered by pressure. In an instant, the Tsata Bridge, Russia's pride, collapsed. Concrete pillars ripped apart, the deck folding, massive steel beams crashing into the river. A black plume soared hundreds of meters, visible for miles. At 5:52 a.m., the Russian convoy was obliterated. Kamaz trucks burned, fuel spilling into the river, turning it into a sea of fire. Secondary explosions tore through as ammo cooked off. Russian soldiers screamed, then were drowned out by detonations. Some leapt from their vehicles but were thrown down by the shockwave. Many left unconscious. A few crawled away, only to be consumed by the flames. At 5:55 a.m., the entire area was an inferno. Explosions echoed back to Russian rear defenses. Black smoke towered into the sky, a signal of disaster. The supply convoy, the hope of sustaining combat across multiple fronts, was gone in seconds. On screens in Kyiv, officers of the 58th Separate Mechanized Infantry Brigade sat in silence. They had just witnessed one of the boldest operations of the war. A strike that not only destroyed a convoy, but severed a critical Russian logistics artery. At 6 a.m., no cheers, no shouts. Only heavy silence engulfed the 58th Brigade's Special Operations Unit. The commander lifted the radio, his voice firm, emotionless. Target destroyed. Mission complete. This was the trademark of the 58th Brigade. Ghosts on the battlefield. They make no noise, leave no trace. But when they strike, the enemy always pays in ruin. The consequences were immense. The Tsata Bridge, a vital Russian supply artery, destroyed. The convoy with hundreds of tons of fuel and ammunition reduced to ash. A cheap UAV delivering the effect of a large-scale airstrike, proving asymmetric warfare and Ukraine's superior flexibility. At exactly 9:30 a.m., August 15th, 9 Ukrainian suicide UAVs simultaneously closed in on the Elastic gunpowder plant in Tver Oblast, a facility capable of producing hundreds of tons of propellant per day and storing up to 30,000 tons of munitions, equivalent to the ammunition reserves required for a major campaign by a top 5 military power such as Germany. Every artillery shell fired in Bakhmut, every mortar barrage landing on Kherson, even the missiles launched toward Kharkiv, could trace their origin back to this site. The wild pack had traveled more than 400 miles from the direction of Chernihiv to get here. But a prize like this never comes easily. Surrounding Elastic was an armor of defenses worth hundreds of millions of dollars. Podlet K-1, Pol 21, and Pantsir S-1, systems that had previously defeated both American UAVs and Chinese cruise missiles. To avoid detection and jamming by that defensive shield, during the final 30 minutes of their approach, all 9 UAVs had to cut off GPS guidance. No communication, no remote command, only cold algorithms remained, driving them straight toward the target. It was like driving in the dead of night with all headlights switched off, the driver relying solely on memory to feel his way forward. And in just a few minutes, these cheap composite airframes, assembled from civilian engines and off-the-shelf parts, would prove that a low-cost weapon could still blow apart an ammunition depot worth billions of dollars. Unlike commercial drones modified for reconnaissance on the battlefield, these 9 UAVs were built for one purpose only: to strike and detonate. They were UAV Beavers, Bober, long-range suicide drones developed by Ukraine specifically for deep strikes inside Russian territory. With composite fuselages and a takeoff weight of about 110 to 120 pounds, each Beaver carried a shaped charge warhead containing 13 to 15 pounds of high explosives. A simple 2-stroke engine maintained a cruising speed of 100 miles per hour, slow but steady enough to complete the long journey. Throughout the flight, Beaver relied on GPS combined with an inertial navigation system to stay on course. But upon entering the jamming zone, GPS was cut. At that point, navigation depended entirely on Inertial System IMU, Magnetic Compass. Preloaded 3D terrain maps. Electro-optical over infrared cameras to see the ground and self-correct against fixed landmarks. The 9 hunters did not fly scattered. They were linked by a low bandwidth, anti-jamming data link, automatically maintaining formation. The electro-optical over-infrared camera on the lead UAV locked onto the propellant storage complex. This was no random aim. The feed was transmitted directly into an image recognition system, trained with thousands of satellite images of Elastic. The algorithm didn't just see the plant, it understood the structure. Rows of connected warehouses, a rail spur cutting through, storage tanks aligned along the side. In a blurred 640 by 480 pixel frame, the long rectangular blocks glowed white with heat. Warehouse A1, 125 degrees Fahrenheit. Warehouse B2, 120 degrees Fahrenheit. Warehouse C3, 115 degrees Fahrenheit. A difference of just a few degrees was enough to reveal the secret. Warehouse A1 had just been filled with propellant, maximum pressure, maximum volatility, maximum destructive potential. That was the weak point, the primary target. At a range of 15 miles, the UAV formation split. The algorithm automatically assigned tasks. 03 UAVs locked onto Warehouse A1 to ensure a strike on the weak point. 02 UAVs turned toward the Iskander section, where strategic warheads were concentrated. 2 UAVs targeted the Toshka U storage. 2 UAVs veered south, selecting the railway line as their target to sever the transport lifeline. Each UAV maintained an approach angle offset by 5 to 10 degrees, creating a crossfire field. A classic artillery tactic, this time executed by a fully automated control system. Elastic was not an ordinary military facility. It was Russia's strategic-level ammunition storage and production site, with massive and diverse stockpiles. Over 30,000 tons of propellant, artillery shells, and missiles. Iskander and Tochka U missiles, continuously used by Russia in the war in Ukraine. Cab 500 to Cab 1,500 guided bombs. A large quantity of 120mm mortar rounds, the backbone weapon of Russian artillery units. And, according to Ukrainian intelligence sources, even some weapons imported from North Korea. The plant's structure dated back to the 1960s. Concrete walls about 12 inches thick, sheet metal roofing, and rail spurs directly linked to the regional rail network. This design was meant to withstand free-fall bombs from B-52s during the Cold War, but it was utterly unsuitable against the threat of low-flying suicide UAVs in modern warfare. Elastic was protected by multiple layers, a Podlet K-1 low-altitude radar, a Pantsir S-1 system armed with 1257 E-6 missiles and twin 30mm autocannons. A Pole 21 jamming network covering the entire area. When the drone formation was still about 20 miles from the plant, the first defensive layer went into action, the Podlet K-1 low-altitude radar. The Beaver's flight algorithm had already accounted for this. At altitudes of only 160 to 200 feet, the Podlet could realistically detect targets at a maximum of 15 miles, and that only under perfect conditions without interference. But in Tver, buildings, birch forests, and a thermal inversion bent the radar beams, turning signals into flickering blips resembling migrating birds. On the Podlet screen, the system automatically classified them as background noise, no threat detected. The first chance was lost. At a distance of 12 miles, the second defensive layer activated, the Pole 21. Russia was confident this electronic bubble would throw any Western UAV off course. Transmission stations pumped continuous false GPS signals, tricking navigation units into believing they were thousands of miles away, sometimes even over the Pacific Ocean. But the Beaver was not flying by GPS in its terminal phase. Its navigation relied on inertial systems, magnetic compass, preloaded 3D maps, and electro-optical over infrared sensors. The flight path was pre-calculated, independent of satellites. As a result, that electronic bubble was no more effective than trying to infect a dagger with a computer virus. The Pole 21 broadcasted in vain. All 9 beavers held formation, continuing their approach toward Elastic. At exactly 10:29 a.m., when only 9 miles from the target, the final blips appeared on the fire control radar screen of a Panzer S-1 battery positioned right next to Elastic. Altitude 200 feet. Speed 100 miles per hour. The operator on duty frowned. At that speed, the target was too slow to be a fighter jet, too fast to be a bird, and too low to be a civilian aircraft. He immediately swung the electro-optical sensor turret and zoomed in to maximum. On the thermal display, a small bright spot stood out against the cold ground. 4 propellers, a central fuselage, unmistakably a drone. Then another appeared, and another. A quick count. At least 8 signals spread across a front nearly 2 miles wide. The range meter dropped rapidly. 6 miles, 5 miles. At the current speed, just over 180 seconds remained before impact. Without waiting for higher command, the operator slammed his finger onto the automatic fire button, overriding all safeties. The first 57 E-6 missile roared out of its tube, belching white flame, accelerating to Mach 2.8 in just 3 seconds. All fire control systems switched to radar-guided homing mode, but the signal was unstable. The blip on the screen flickered like a dying bulb. The missile's seeker struggled to hold lock, a target too small, nearly vanishing from the electromagnetic spectrum. At 1.2 miles, the proximity fuse began calculating. It searched for a radar reflection large enough to trigger, but the Beaver UAV was too small. Result, the system decided this was not a valid target. The missile streaked past, missing by only a few yards, close enough to create a supersonic shockwave that shook the UAV, but caused no damage. The launcher immediately fired a second round. But this time, the targeted UAV executed its pre-programmed jump maneuver, climbing an extra 65 feet in 2 seconds, then diving back down to 100 feet. The guidance computer, accustomed to the steady flight paths of aircraft, lost the track entirely. The second missile shot into empty sky, detonating off target. In less than 30 seconds, all 9 UAVs had penetrated every defensive layer. They split into 3 groups, each separated by several hundred yards, flying so low they almost blended into the terrain. At exactly 10:31 a.m., all 9 drones were now within 2 miles of the target. At this point, only the twin 30mm autocannons remained. But to fire, their barrels had to point directly toward the ammunition depot. A single stray burst could finish the enemy's job for them. In 40 seconds, impact was inevitable. The Russian soldiers understood they had lost control. At 10:31 minutes and 30 seconds a.m., all UAVs simultaneously shifted into their final attack run. The algorithms locked hard onto coordinates, cutting all data link channels. From this moment, no command, even from Ukrainian operators, could alter their course. Each UAV held its heading, altitude descending, 200 feet, 160 feet, 130 feet. The 2-stroke engines screamed at full throttle, holding a steady 100 miles per hour. Their trajectories were now arrows already loosed. There was only one destination, the pre-assigned target. At 10:32 minutes a.m., all 9 UAVs plunged into their targets. Drones 1, 2, and 3 dove straight into the Iskander warehouse roof like knives piercing an overinflated balloon. Their 13-pound shaped charge copper warheads punched through the sheet metal roof, drilling fiery jets inside. At 0.02 seconds, the fuses triggered. At 0.20 seconds, internal pressure exceeded structural limits. The shockwave expelled air at nearly 9,200 feet per second. The entire block shuddered like a beast struck in the spine. The 0.3-inch steel roof was no longer a roof. It became a 15-ton steel plate, hurled skyward and crashing down nearly 660 feet away. Reinforced concrete walls split apart, rivets scattered like rain. Steel beams collapsed onto the factory floor like the bones of a fallen dinosaur. UAVs 4 and 5 slammed into the Iskander storage area, where Russia's strategic warheads were concentrated. Within 0.03 seconds, their fuses detonated, blowing apart the entire bay. The shockwave cascaded through dozens of Iskander missiles stacked inside. Armed sub-fuses sprang awake, igniting a massive fireball that shot hundreds of feet skyward, black smoke curling into a mushroom. UAVs 6 and 7 locked onto the Toshka U depot. These tactical ballistic missiles, built since the Soviet era, nearly 23 feet long, lay horizontally in the low-roofed warehouse. The fuses triggered. Just 0.05 seconds later, the first Tochka ignited. It did not explode alone. The shockwave swept the entire row, forcing the next warheads to ignite. One, then two, then the entire line. Successive detonations pounded like hammers on a war drum. Each beat a multi-ton missile torn apart. The Tochka U block became a giant forge. Molten metal glowed red. Shards several feet long tore outward, embedding deep into the ground like spears. In under 1 minute, 2 tactical weapon depots, Iskander and Tochka U, were erased. UAVs 8 and 9 struck the railway line, the artery connecting Elastic to Russia's entire front line. The impact showered sparks. In seconds, Elastic's strategic railway was severed. No train could arrive or depart. The entire logistics chain, feeding the front lines, collapsed instantly. The factory's automatic fire suppression system activated, spraying 2,600 gallons of foam per minute. Foam rained down, consumed by heat within 2 minutes. The system had been designed for small fires, not multiple chain explosions. From the local fire station, 2 10-ton tankers sped toward the site. Heat radiation gauges spiked 50 kilowatts per square meter at 330 feet. The crews were forced to stop at the perimeter, helpless as thermometers pegged maximum. 6 to 8 kilometers away, several dash cams recorded the sky suddenly changing color. Not a cloud, but a mushroom of smoke. In the workers' housing blocks, fire alarms howled before going silent. The power lines had been cut. A child asked his mother, "Why did a second sun rise at noon?" At 0.6 miles, the fire chief spread an industrial map across his car hood. All approach routes were blocked by thermal walls. He pointed to the western drainage channel, ordering an earthen dam, not to stop the fire, but to block burning runoff from reaching residential areas. That afternoon, commercial satellite imagery from Maxar was released. The before and after shots exposed the devastation. Before, an industrial complex with warehouses, storage depots, rail lines, and a green belt of trees. After, a vast black scar. Warehouses gone, sheet metal and concrete melted, storage depots reduced to rubble, rail lines twisted like molten candy sticks. Even the surrounding forest was scorched into concentric rings, a perfect imprint of the blast's intensity. From above, Elastic looked as if erased by a tactical nuclear strike. OSINT sources later estimated the blast destroyed about 160,000 tons of ammunition. Among them, 30,000 tons of artillery shells and mortar rounds, dozens of Iskander and Tochka U missiles, multiple consignments of cab-guided bombs, nearly 50% of Russia's 120mm mortar stockpile, the backbone of its trench artillery. To visualize, 160,000 tons of ordnance equaled the combined firepower of dozens of artillery divisions for months, and in under 10 minutes, it was gone. News of the blast reached the battlefields of Donetsk and Kursk within hours. Russian artillery units, which had been firing 500 to 600 shells per day, were forced to scale back. 120mm mortars, the weapon accounting for 70% of all trench firepower, were now in critical shortage. In many sectors, Russian gunners were ordered to fire sparingly, shifting from saturation bombardment to selective targeting. Some batteries even had to request ammunition from neighboring regions. Elastic was not just an ammunition depot, it was a lifeline. When that artery was severed, the entire body of war weakened instantly. Each improvised UAV was estimated to cost about $20,000, even less when calculated with AliExpress component prices. In total, 9 UAVs, less than $200,000. In return, Russia suffered losses in the billions: ammunition, infrastructure, and most critically, confidence in its defenses. It was a bitterly lopsided equation. A few sheets of composite, a two-stroke engine, and a warhead of just a few kilograms had annihilated an entire strategic weapons stockpile. From Moscow, Russian generals could not look away. If a facility located more than 190 miles inside Russian territory, protected by radar, Panzer, and Pole 21, could still be wiped out so easily. What fate awaited the others? Most importantly, Ukraine had proven that modern war does not require billion-dollar long-range missiles or strategic bombers. Sometimes, just a swarm of cheap UAVs, guided by intelligence and absolute determination, was enough to rewrite the battlefield. August 12, 2025. A Russian convoy carrying about 50 tons of ammunition moved into a refueling stop. But only minutes later, 2 first-person view suicide drones surged forward at nearly 125 miles per hour, like deadly arrows piercing straight toward the trucks. 2 strikes in less than 5 minutes, and the entire stockpile erupted. The blast could be seen from more than 12 miles away. This was not just a raid. This was the moment the rear lines turned into the front line. At 10 a.m., August 12, 2025, from a makeshift launch site near Svatov, on the outskirts of Starobilsk in Luhansk, 2 first-person view suicide drones of Ukraine's 14th Tactical UAV Regiment entered their final checks before a strategic strike. 15 minutes earlier, a modified DJI Mavic 3 had been launched. It acted as the scout, capturing infrared images, transmitting real-time data to the command post, and guiding the 2 attack drones toward their targets. The target, 5 Russian Ural trucks loaded with ammunition, moving toward the improvised relay hub, Idar 17, on the north bank of the Idar River. Their mission was to deliver over 50 tons of artillery shells and rockets, enough to increase Russian fire density to levels that could threaten Ukraine's supply routes, staging areas, river crossings, and forward medical stations. But Ukraine would not allow that to happen. For days, the 14th Regiment, working with intelligence networks, had tracked the convoy, marking refueling times, crew habits, and combining UAV imagery with electronic reconnaissance to pinpoint the moment the trucks would have to halt for inspection and refueling near Starobilsk. The location lay outside the umbrella of fixed air defenses. No radar, no missiles, no electronic warfare teams. At 10:02 a.m., from 9 miles out, the Mavic 3 streamed encrypted real-time video back to the field command post. On screen, the 5 engines glowed as distinct heat signatures. To Ukrainian eyes, it was a perfect cluster target. A single precise strike could set off a chain reaction, wiping out the entire convoy in under a minute. No further confirmation was needed. Signal encrypted. Coordinates locked. Immediately, the 2 FPV drones launched. In the initial phase, they used GPS combined with inertial navigation, flying low at an average 35 to 50 feet to evade ground radar or low-frequency surveillance. Cruise speed was held steady at 80 miles per hour, fast enough to shorten the flight time, yet slow enough for the operator to maintain pinpoint control. At 2 miles out, The drone's optical cameras acquired the target. 5 military trucks parked with 20 to 25-foot spacing, all facing south. Several soldiers walked nearby, but there was no sign of guard posts or improvised defenses. Just as intelligence suggested, this was treated as a short, safe stop. Each drone carried a PG-7VL-shaped charge warhead, weighing 5.5 to 6.5 pounds, fitted with an 85mm copper liner. Inside was 1.5 to 2 pounds of OK-Fall explosive, equivalent in power to high-grade TNT. Upon detonation, it produced a focused jet exceeding 32,800 feet per second, enough to pierce 0.6 inches of truck steel plating and ignite the ammunition within. Originally designed to penetrate 20 inches of tank armor against lightly armored transports, its effect was overkill, like smashing an eggshell with a sledgehammer, not only piercing but triggering uncontrollable secondary explosions. The aim was not to destroy trucks individually, but to hit the formation's vital points, truck number 3 at the center to start the chain reaction, and truck number 5 at the rear to lock the convoy in place. With these positions struck, the heat and shrapnel from the initial blasts would cascade through the rest. At 10:03 a.m., at only 1,970 feet away, both drones entered their final approach. Navigation switched fully to optical recognition, altitude dropping from 33 feet to 16 feet to stabilize the flight path and avoid detection. UAV-1 locked onto truck number 3, the perfect central kill point to ignite a spark explosion and spread heat into adjacent vehicles. The FPV crew commander kept the approach steady for the first 5 seconds, then ramped up to linear acceleration. At just 98 feet out, UAV-1 surged to 87 miles per hour, a steel arrow carrying compressed explosive mass, tearing through the air, slamming into the structural weak point, and locking the entire convoy into chain reaction detonation. On impact, the shaped charge ignited. A jet of hyperheated plasma burst through, shredding the truck's steel like foil. The penetrator's force focused on a spot just a few centimeters wide, but the contact temperature instantly spiked to 5,100 to 5,400 degrees Fahrenheit. Propellant charges, fuses, and packaging inside the truck ignited almost immediately, generating intense heat through a chain reaction. Within 5 seconds, the entire cargo bay had become a burning time bomb from within. The heat spread directly to the 2 adjacent trucks, vehicle number 2 in front and vehicle number 4 behind, forcing the entire formation into thermal overload. This was the moment the battlefield shifted into full chain detonation mode. The sound of the first blast and a towering column of fire sent the escort troops into panic. Some soldiers fired wildly with AK rifles, aiming at the silhouette of the remaining drone as it flashed past. But at that distance, with the drone's closing speed, small arms fire was meaningless. Others scrambled to maneuver the convoy out of danger, but the spacing was too tight, and the fireball erupting from truck number 3 created a wall of flame that sealed off any escape. In under a minute, the convoy was trapped in place. Almost simultaneously, UAV-2, the second strike drone, executed its programmed flanking run, looping behind to approach from the opposite direction. The target, truck number 5, the rearmost vehicle. This was the critical tactical move. Strike the tail, lock both ends, and trap the entire formation inside a kill zone. The UAV commander adjusted UAV-2's speed to 75 miles per hour, just enough to maintain an optimal angle of attack without overshooting the target while keeping the optical lock steady. It veered diagonally from the rear right, slamming into the cargo bay of truck number 5. The shaped charge punched through the shell, detonating in a second fireball. Flames erupted, merging with the blaze of truck number 3, creating twin pillars of fire engulfing the formation. At 10:04 a.m., truck number 3 detonated completely, unleashing a shockwave across the entire convoy. The blast ripped apart truck number 2's steel shell, hurling shrapnel into truck number 1 at the front. The chain reaction had begun. Moments after truck number 3's total detonation, local temperatures surged past 6,332 to 7,232 degrees Fahrenheit. Fire columns and shock waves hammered into the neighboring trucks. Truck number 2 erupted violently. Paint, plastics, and external coverings ignited in under 10 seconds. Successive blasts turned it into a mobile fireworks battery. The rising pressure blew open the cargo bay, venting fire straight upward into a massive thermal column, a textbook case of detonation cook-off, where propellant self-detonates after surpassing safe thermal thresholds. Truck number 4 suffered a dual strike, residual flames from truck number 3 in front and the inferno from truck number 5 behind. The compounded heat triggered a full detonation of its load. This was the third major blast in under 2 minutes. Steel fragments and artillery shells were hurled more than 495 feet, damaging nearby infrastructure. With 3 successive explosions, Starobilsk was transformed into an uncontrollable firestorm. Fire pillars shot tens of meters into the air, with black smoke visible from over 12 miles away. Each blast scattered new fragments, endangering every Russian soldier nearby. Secondary detonations continued as shells and rockets in the cargo bays ignited at random. Truck number 1, initially intact, was torn apart by shockwaves from truck number 2's explosion. Shrapnel punctured the cabin and cargo bay, spreading fire. Within seconds, truck number 1 was fully ablaze. At this point, all 5 trucks were destroyed. At least 4 completely detonated, reduced to twisted wreckage. Moments later, blue flames jet skyward as transformer oil burns fiercely, merging with the dense black smoke already billowing from the earlier fuel depot strike. Flame and smoke fuse into a towering wall that blankets the entire industrial. The operational result was indisputable. With just 2 drones and 2 precise strikes, the entire convoy of 5 ammunition trucks was annihilated. 40 to 50 tons of artillery shells and rockets were destroyed in under 3 minutes, the dual fire centers locking the formation and driving the chain reaction until every magazine was consumed. Exact figures remain unknown, but with an average crew of 3 to 4 soldiers per truck, drivers, escorts, technicians, plus guards, casualties are estimated at 20 to 25 personnel. The blast deformed the concrete roadway and heavily damaged surrounding infrastructure. Russia was forced to cordon off the area due to large amounts of unexploded ordnance. Immediately after, the Russian Emergency Situations Ministry, along with EOD teams, firefighters, and medics, moved into the hot zone. Route P66 was sealed, and ambulances stood by along the safety perimeter. This strike did not merely destroy a convoy. It sent shockwaves through Russia's entire logistics system in Luhansk because it severed the Starobilsk-Svatove-Kupiansk supply route, the key artery feeding ammunition to Russian artillery groups in northern Luhansk. Post-blast clearance and demining would stall transport for at least 5 to 7 days. Eliminated an ammunition stockpile equivalent to half a month of fire support for a Russian artillery regiment in a single night. Forced Russia to change its transport model, from concentrated convoys to dispersed smaller units with tighter escort. This cut efficiency, raised costs, and slowed resupply. The attack proved there is no such thing as an absolute safe zone in the rear. Even Starobilsk, long regarded as an untouchable logistics hub, was penetrated and struck with precision by Ukrainian drones. It also increased pressure on Russian commanders to secure their supply lines. They would be forced to deploy more air defenses, jamming units and escorts, resources already stretched thin on the front. Ukraine has repeatedly demonstrated that with low-cost drones, it can strike directly at Russia's logistical arteries, turning mobile depots into priority targets. This aligns with Kyiv's strategy of attrition warfare. For 1 to 2 weeks after the attack, Russian artillery capability around the Kharkiv-Svatove axis is likely to diminish. This could open a window for Ukraine to redeploy forces, or at the very least, reduce pressure on defensive lines. It is also a direct warning. Every Russian logistics convoy, anywhere, large or small, can be a target. No road is absolutely safe anymore. At exactly 3:20 a.m. on August 28, 2025, a Bayan-M warship belonging to Russia's Black Sea Fleet, worth nearly $80 million, was docked at Military Pier No. 2 in Temryak Bay, an inland area considered by Moscow to be untouchable, more than 65 miles from the Ukrainian front line. The vessel had just returned from a strategic caliber strike mission and was now in resupply mode, refueling, activating the cooling system, and especially reloading 8 caliber NK cruise missiles, each worth over $1 million, with a range of more than 950 miles, capable of reaching any city in Ukraine. On the deck, a group of officers was gathered, raising vodka glasses to celebrate the recently completed mission. The combat crew was rotating rest shifts. Some had fallen asleep at control stations. No one knew that just over 6 miles away, a high-speed boat bearing civilian markings was silently gliding across the water, slowly approaching the bay. From the outside, the speedboat looked like a regular fishing vessel, but inside the cockpit were 2 Ukrainian soldiers from the 73rd Naval Center, dressed in fishing jackets and Russian-style fisherman caps. Behind them, in the storage compartment, where there should have been styrofoam boxes filled with squid and herring, were 2 Beaver model FPV suicide drones, heavy configuration, equipped with 8-pound armor-piercing warheads, night vision cameras, and internal navigation systems independent of GPS. And in less than 5 minutes, that small boat would become the mobile launch pad for one of the boldest naval attacks Ukraine had ever carried out, right in the middle of a zone fully controlled by Russia. The Bayan-M warship is a compact but extremely dangerous war machine. Unlike massive ships that carry helicopters and heavy air defense systems, the Bayan-M is designed for narrow inland waters like the Caspian or Azov, but still capable of striking nearly any target in Ukraine. Each time this ship leaves Temryak port, considered the cocoon of Russia's Azov fleet, cities like Kyiv, Lviv, or Odessa face new uncertainty. No one knows what the next target will be: a power grid, a fuel depot, or a kindergarten. Ukraine knew this well, and they decided not to wait for the next launch. They would strike first. The defense system around Temryak port, where the warship was docked, was extremely dense. This was no ordinary port, but a floating air defense fortress. A Panzer S-1 system, specialized in intercepting UAVs and cruise missiles, 2 Podlet K-1 radar stations on active duty 24/7. This meant every layer of armor was active. Any unknown object that appeared would be shot down almost immediately. And so, the Russian Navy believed Temryak Bay was a steel nest, where no UAV could get close. But that was a fatal mistake, because Ukraine had calculated the exact timing and chosen a method the enemy wouldn't expect: skimming the sea surface, the radar blind zone, a gap so narrow it seemed harmless. But from that very place, death approached silently, with the weapon Russia least expected: a UAV costing just 1/500th of a caliber missile. At exactly 3:27 a.m., when the boat was just 3 miles from the target, right on the outer edge of Temryak port's surveillance ring, the 2 Ukrainian soldiers in the cockpit moved quickly. They removed the gray camouflage tarps covering the back compartment. From beneath, 2 FPV drones emerged. Each drone was about 4 feet long, with a wingspan of 5.5 feet, the body made of fiberglass composite, ultralight, low thermal signature, matte gray to blend in with the sea. As soon as everything was ready, the 2 soldiers pulled the safety pins, activated the internal navigation modules, and pressed arm and release. The 2 UAVs were deployed using an independent dual strike model, 2 approach vectors, 2 separate targets, fully synchronized in time and tactics. The first, codenamed Hram, Thunder, controlled by the primary group, was programmed to fly directly toward the surveillance radar tower to disable the main radar system, temporarily blinding the Russian warship. The second, codenamed Vidplata, Retribution, operated by HUR Special Operations Forces, would follow from a 30-degree offset on the right flank and strike the Kaliber missile launcher amidships, which held all 8 Kaliber NK cruise missiles. If Hrom succeeded in blinding the radar, Vidplata would have the chance to pierce the final armor layer and strike at the heart of the warship, where not only the missiles were stored, but also the fire control command center. At exactly 3:29 minutes and 12 seconds AM, the first UAV was pushed off the launch rail at the stern of the boat. In just 3 seconds, the high-speed electric propeller activated, the UAV accelerated and took off, flying just above the water's surface. The second drone followed 40 seconds later. Both UAVs flew approximately 200 feet apart, at an altitude of no more than 7 feet, low enough to slip beneath the scanning angles of the Podlet and Pantsir radars. From that moment on, the boat had completed its mission. Everything that followed was entirely in the hands of 2 unmanned killing machines, guided by internal navigation algorithms, inertial sensors, and infrared cameras. Inside a control bunker near the city of Zaporizhzhia, a UAV operator from the primary unit stared intently at a black and white FPV screen. Everything around him was dead silent. Only the dim glow of the monitor illuminated his tense, motionless face. The radar tower loomed on the screen, a near-perfect target. The operator held his breath. The Hrom drone was closing in, just a few hundred feet to go. The distance readout showed 950 feet, then 800, then 650. Still no reaction from the Russian vessel. Its radar kept rotating, unaware of the incoming threat. The operator tightened his grip on the control stick. The countdown began. 5 seconds. 4, 3. In that instant, everything went still. At exactly 3:31 minutes and 25 seconds AM, a bright flash erupted directly on the main radar mast, followed by a white plume slicing across the deck. Flames burst out on both sides like massive welding torches. Shrapnel scattered, splashing into the sea like fireworks. Just 0.7 seconds after Hrom struck, the entire surveillance and navigation system of the Bayan M simultaneously shut down. The main antenna was ripped from its rotation shaft and flung across the deck. The signal transmitter shorted out, sending sparks into the equipment compartment. The explosion's heat singed auxiliary sensor clusters. The central data processor, shielded by EMI protection, was completely knocked out. The Bayan M, once a powerful long-range strike platform, was now in a state of temporary tactical blindness. The ship's commander immediately gave the order, "Run a fast diagnostic on the sensors, possible electronic warfare attack." But the responses were hopeless. Main radar, completely destroyed. Bayan M now had only one hope of survival. The Pantsir S-1 close-in defense system with an engagement range of 2.5 to 3.5 miles, but it had to be activated manually by the crew. However, after Hrom's strike, the control center had been destroyed and cabin temperatures surged, making it impossible to trigger the support defense system. Part of the composite shell on the command tower was ripped open, allowing sea wind and carbon dust from the blast to pour in. A radar officer was critically injured. A shard from the antenna penetrated the observation window and struck his left chest. Within less than 10 seconds, the entire defense crew was thrown into chaos, losing command capability temporarily. And this still wasn't the end. Now the real threat arrived from an angle no one anticipated. At 3:31 minutes and 25 seconds AM, just 6 seconds after the first strike. From the port side, a small gray object skimmed the surface at nearly 95 miles per hour, heading directly for the Kaliber launcher section amidships. It was Vidplata, Ukraine's FPV drone known as Retribution. Vidplata's target was the center deck, where the 3 S-14 vertical launch system was located, housing up to 8 Kaliber NK cruise missiles. In the auxiliary control room, a watch officer shouted, "Low-level object approaching, port side," but it was already too late. The radar was down. The optical camera was obscured by burned dust. The Pantsir battery had not been ordered to fire. The command crew was still trying to reboot the system. The Boyan M was now completely exposed to the second strike. The FPV feed from Vidplata captured every launch bay clearly. Rectangular hatches painted in matte grayish-green, protruding from the deck like flat horizontal chimneys, arranged in parallel rows along the ship's center line. Heat signatures were visible from at least 2 launch covers. One of them, bay number 3, had its hatch open, exposing part of a Caliber NK already in pre-launch mode. That was the critical point Vidplata had been programmed to hit. It immediately veered in from the port side, approaching at a 25-degree angle relative to the ship's longitudinal axis. Exactly 3:32 a.m., Vidplata slammed straight into Launch Bay 3. A powerful explosion blew the hatch clean off. A thick column of black smoke shot dozens of feet into the air. The blast tore apart part of the center deck, steel plating bent, metal fragments scattered like shrapnel. Immediately after impact, the ship's internal fire suppression system activated. Carbon dioxide valves popped open along the deck. Compressed gas was sprayed in bursts to extinguish flames and reduce heat. But it was already too late. Fire spread into the secondary electrical bay. The launch control module was incinerated. The 2 adjacent launch bays overheated rapidly. The risk of a secondary explosion couldn't be ruled out. And above all, the ship had completely lost its combat capability. After the blast, the vessel began tilting 3 to 5 degrees to the right, a clear sign of internal imbalance or a flooded technical compartment. Crew members rushed to inspect the deck. Emergency valves were sealed. The entire defense system was switched to manual mode. The ship did not sink, but at this point, it had lost all defensive and offensive capability. The UHF band internal military communications channel of the Black Sea Fleet received the message, Boyan M warship B-38 attacked, radar damaged, caliber system damaged, requesting support and tow back to Temryuk. Less than 7 minutes after the dual strike, the Boyan M had completely lost its combat capability and was forced to withdraw from its active post in Temryuk Bay. The Boyan M serves as Russia's main strike platform in the Sea of Azov. Due to the sea's semi-enclosed, shallow water and narrow channel terrain, only small-class ships like the Boyan M can operate effectively, evading enemy radar while launching long-range cruise missiles. And now, at least one has been knocked out of the fight. Just hours after the attack, Ukraine's Defense Intelligence Directorate released UAV footage clearly showing the first strike hit the radar, destroying the top of the mast. Seconds later, a second drone slammed into the center deck. Flames erupted. The ship tilted noticeably. No air defense response was observed. Trusted outlets such as Naval News, Kyiv Post, Business Insider, and the Kyiv Independent all confirmed the video's authenticity. According to independent naval experts, the FPV drone attack on the Boyan M warship not only caused direct material damage, but also had immediate strategic consequences across the Sea of Azov. After the attack, the Boyan M was forced to return to its naval base in Sevastopol for assessment and repairs. The process is expected to take at least several weeks, depending on the extent of the damage and the recoverability of its digital infrastructure. For Ukraine, this was a clean tactical victory, achieved at less than 1% the cost of the target, yet with an impact that could shift the balance of power for days or even weeks. The strike dealt a blow to the confidence Russia's navy once had in the supposed safe zone of the Azov interior. To the Russian command, this was the calm rear area, where warships could dock, reload, and prepare caliber strikes without fear of pursuit. But reality has just proven the opposite. 2 FPV drones, launched from a disguised speedboat, not only penetrated a multi-million-dollar air defense system, but struck the 2 most critical vulnerabilities of a warship, its radar and missile launch system. And this wasn't the first time a Russian warship had been hit by improvised drones. Back in late 2024, Ukrainian special forces used improvised UAVs to disable a Sergei Kotov-class patrol boat off the Crimean coast, forcing it to remain docked for repairs. That same year, a Cesar Kunikov-class landing ship was completely sunk during a drone-based amphibious strike. More recently, in July 2025, Ukraine deployed a sea-launched FPV drone for the first time to strike an offshore oil rig near Crimea used by Russia as a radar station, a move Western analysts described as a turning point in asymmetric warfare. These are no longer desperate ramming attacks, but well-executed operations, with planning, rehearsal, and synchronized timing, using small, inexpensive weapons that know how to exploit blind spots, hit at the right moment, and strike the right target. It's not that each individual UAV deals a fatal blow. Rather, it's the intelligent, coordinated, and unconventional use of them that has turned these drones into the Russian Navy's strategic nightmare of the 21st century. From this point forward, any Russian vessel operating in the area, whether it's a Bayan-M, a Cerna-class, or a logistics ship, must now face the ever-present threat of UAVs that cost less than $2,000 apiece. At exactly 3 a.m. local time, on August 29, 2025, as the Russian S-400 Triumph air defense system in Jankoy began its new duty cycle, the 91N6E radar spun its deadly rotations, emitting pulses of electromagnetic waves that cut through the Crimean night sky. The entire crew on duty still believed they were manning one of the most formidable air defense rings in the world, completely unaware that the $500 million radar station's remaining lifespan was now measured in minutes. From deep within a forest east of Mykolaiv, nearly 155 miles from Jankoy, a camouflaged Kamaz truck extended its hydraulic hatch under the cover of foliage. Inside was a weapon never before revealed, a Flamingo cruise missile developed by Firepoint Industries, an ultra-low-flying dagger